Okay, so I've called this 3.5, and what it's going to be is looking at moving on and what our next steps are going to be, because the next three chapters or the next three units are going to be quadratic. So when the one obvious next step is converting a quadratic equation from factored form to standard form. And we talked when we did the FOIL lesson about how important FOIL is as a math procedure, and how important it's going to be to convert between factored form and standard form. And when we have the vice versa, or the next way, or going backwards, from standard form to factored form, that is going to be what is in the next chapter. The other next step maybe isn't so obvious. We want to look at what happens when you have an exponential graph. So yes, having a squared makes our graph not linear, but what happens when you have something other than squared? How is the graph going to look? So we're going to take a look at that as well and see how that's going to play out, okay? So first we will look at an equation, and this equation is in factored form. X minus r, x minus s, where the a value is 1. And so when you have equation in factored form, then those are the zeros. So our zeros are +1 and -3. So you could do all of the things that we did before. You could just change the sign. You can set what's inside the brackets equal to 0, whatever version you liked, okay? So we get +1 and -3. The y-intercept is a little easier than the vertex, so I'm going to do that first. When x equals 0, okay, so my parabola has to cross the y-axis at -3. The only trick is now we should really use the vertex too. Now, next section, chapter 5, we are going to look at how you can use the step pattern to help. But the vertex, even when we try to use the step pattern, is going to be quite important, okay? So with the vertex, we are going to use the zeros to solve for the x value. So we have +1 and -3. We need to know where the halfway point. We want to cut our parabola into 2 equal pieces. So we have -2/2, which is -1. And once you have an x value, you can sub that in and solve for y. -1 and -4. Okay, and then if you look over 1 up 1, there's the y-intercept. Over 1 up 1, 2, 3 gives us the first 0. If I go the other way, over 1 up 1, over 1 up 1, 2, 3, and now I have enough points to sketch my parabola. Okay, so if you have factored form, you do have to do, a pretty significant amount of algebra in order to get it to be a usable form, but that's okay. All right, so if we have standard form, which of course is the expanded and simplified version, the degree can tell us if the equation is quadratic or not. So if the degree is 2, so in standard form, we're going to have x squared, and the standard for standard form is to write the x squared term first. Okay, so we did that when we did 3.4 in the FOIL lesson. So when you have an equation in factored form, like y equals x minus 1, x plus 3, we don't really know for sure what the degree is. The equation is not in standard form, it's still in factored form. But now we can use FOIL to change from factored to standard form, and then we can use the degree to see if it's quadratic. Okay, so I'm going to expand and simplify. That's what a FOIL question would say. And when you expand and simplify our equation, you're going to convert factored form. Actually, I'll write it better. Hold on. So we're going to convert the equation from factored form into standard form. All of those are the same thing. Even though yesterday when you did FOIL, you didn't have many equations that said y equals, that's okay. That's essentially what we are going to do with our expressions. We have the x values, we have these x-intercepts, and we want to find what the y value is going to be, okay? So sometimes it'll be 0 if it was the x-intercept. There's all kinds of things that we can do with that. We can look at the direction of opening. We can use the c value to tell us what the y-intercept is. The direction of opening can tell us if it's a maximum or minimum. And maybe it doesn't really matter if it's random x, y values, but if you're trying to make money and your profit is modeled using a quadratic equation, if you have a minimum value, then that would be the minimum profit. That's a big deal. If you have a maximum value, that's the maximum profit. That's also a big deal. So you want to make sure you do double distribution or FOIL, and you can draw the arrows or not. So you can leave the y equals. We want our x squared term first for standard form. So x times x is x squared. Then outside, x times positive 3 is positive 3x. Inside, negative 1 times x is negative 1x. And whether you put the 1 or you leave it out, again, that doesn't matter. I won't take marks off. So if it helps you to emphasize that it is a negative 1, because of course the middle term we always have to collect like terms, okay? And then the last term is just the number, negative 1 times positive 3 is negative 3. Okay, so collect those like terms in the center. And now we have standard form. We have an a value, we have a b value, and a c value. So now we can see that the degree is 2 and the equation is quadratic. That's a lot of work to just say the degree is 2. You might be thinking, well, Ms. Todd, if I saw 2x terms and I knew I was going to multiply, then you would add the exponents and I would know the degree is 2, which is true, but sometimes the question is going to say, like the second bullet there, convert the equation from factored form to standard form, and this is what you're going to do. So even if you don't have to say that the degree is 2, which means quadratic, then it's still going to be important that you know that factored form can be converted into standard form using FOIL expansion or double distribution. Okay, so when you have an equation in factored form, these were the 3 steps we did. You either had to be given the graph of the parabola so you could find the zeros, or Sometimes the question said the zeros are, and they would have given you 2 values, and then another point in words. So you would had to find the zeros, sub the zeros in as R and S values into the given general form. Of factored form. And then use a point. You can use the vertex. Lots of students like to use the y-intercept because the x value will always be 0. That makes the math a little bit easier when you are subbing in 0. For x and y values, and you can, sub in x, find the y-intercept, and then sub in that x and y value to solve for a. And then if you're only given the zeros, this is a lot of work. You would have to solve for the vertex. That's tough. Okay, that would be a lot of work just to get the equation. Normally you're given the graph or you're given the zeros and one of the points. Okay, that's a little bit less work and less opportunity to make annoying mistakes. Once you have factored form, you're going to FOIL to expand the equation, and be careful if the a value isn't 1. So we practiced some of those, like if you had something like this, I encouraged you to use FOIL first on the 2 brackets, then distribute the 3, okay? That is the best way to keep your equation in standard form. Keep the 2 terms as going to be simply the multiplication a little bit simpler in FOIL, the collecting like terms a little bit simpler, and then distribute the 3 like you would have done even in grade 9, okay? So make sure to always simplify, and we simplify so that our equation looks like standard form. Ax squared plus bx plus c equals 0. And standard form will be given. The general standard form, okay? Actually, I'm going to write that too. General standard form. All right, so a quadratic is a special case of exponential graphs, but there are other cases. So when you have a quadratic, the vertex of the base quadratic, so it's a little bit light here, it's y equals x squared. The vertex is 0, 0. There is symmetry. The zeros are 0. You know what? I'm going to write the x-intercepts. Okay? So when you have the base exponential graph, which is considered to be 2x squared, then it almost looks like a parabola, doesn't it? But it is not. There is no axis of symmetry, and we're going to talk about what the y-intercept is. It's actually always going to be 1, and I'll show you how that works. So when x equals 0, y will be 1. Okay, that is actually a rule, an exponential rule. Good to remember for the rest of your mathematical lives. And there is no vertex, and there is no x-intercepts. And in this graph, it certainly looks like that graph gets to the x-axis. And so I debated whether changing this picture, this one is from your textbook. I thought, okay, let's keep this graph with the textbook so that They can look it up if they want to, but you'll notice that the x and y value do not have the same interval. So the x values are going up by 1, like 0, this is 1, then it's 2, 3, 4, but the y-intercept is not. We have 10, 20, 30. That's quite a difference in the jump. So what happens is with an exponential graph, even a parabola, but especially when you start to have an exponent of 3 or a base of 3, if your base gets bigger, the whole thing with exponential graphs is they get very, very large, very, very quick, or very, very small, very, very quickly. So I'm going to put in Desmos. Y equals 2 to the power of x. And if you look on the x-axis, so the horizontal axis, you might be like, okay, Ms. Todd, I see that touching the x-axis. That red line is reaching the x-axis. And what I'm going to do is zoom in. So right now, every grid line is 1 to 1. When I get smaller and zoom in, what happens is you can see that the line is no longer touching the x-axis, but the grid lines are getting smaller and smaller, and the interval is now smaller and smaller, 0.26, 0.28. And that red line is not touching the x-axis. So the farther you go and the more you zoom in, it gets farther away. Okay, well, let's go find the point where it's going to cross the x-axis. Way so far away, still not touching, still not touching, still not touching. And every time you get to a point where it looks like it's going to touch the x-axis in the Desmos, what you're going to do is zoom in further. Okay, we're getting there. It's almost touching, almost touching. We're getting so close, but still, if I zoom in and get smaller and smaller, it stops touching. Okay, so that means that we call that an asymptote. It does not cross the x-axis, but you'll notice, where does it cross the y-axis? At 1. So that, like I said, is going to be important for the rest of your mathematical lives.
Yeah. So I have to take them to the guy.
Oh, he's here already. Oh, thank you. Thank you. Okay, so when you look at the table of values, if we build a table of value, then what can happen is we can see that relationship as well. So -4 to the power, sorry, that's not right, 2 to the power of -4. Let's deal with that in a second. Let's do the ones that we know. Okay, so 2 to the power of 1 is 2. 2 to the power of 2 is 4. We know that. 2 to the power of 3 is 8. 2 to the power of 4 is 16. So what's happening here each time? We, of course, are multiplying by 2. So 2 to the power of 1 is 2. 2 to the power of 2 is 2 times 2. 2 to the power of 3 is 2 times 2 times 2. Okay? And so what's happening is you're increasing this by the second differences should be, sorry, not the second differences. The multiplication, the division is going to be equal. So what I want you to do is use your calculator and plug into your calculator y equals, or sorry, not y equals, 2 to the power of 0. And you're going to get 1. And remember, this is always going to be the y-intercept, no matter what the base is. when you have an exponent of 0, the y value will be 1. And then what happens is, if you want to keep going, so here at the bottom, when x is 4 and y is 16, and then x is 3 and y is 8, 16 divided by 8 is 2, right? We did 16 divided by 8 is 2. Then the next one, 8 divided by 4 is 2. And 4 divided by 2 is 2. So if there's a mathematical relationship, which we know there is, then it's going to make a nice smooth curve. Then we should be able to do this again. 2 divided by 1 is 2. Our pattern continues. So now, what happens when we plug in -1? And I'm going to tell you the answer. You can put it in your calculator. So you could even follow the pattern. What's 1 divided by 2? And the answer, I'm going to put divide. The answer is either you can write it as 1/2, which is a half. So then if we do 2 to the power of -2, now we have to do 0.5 divided by 2, which is 1/4, or 0.25. If we do 2 to the power of -3, without even putting it in my calculator, I'm going to look at the bottom half. We went 2, then we went 4, then we went 8. So if when the exponent becomes negative, if we have 1/2, then 1/4, I bet this is going to be 1/8. So take a look, or try it out in your calculator. 2 to the power of -3. If you have a Casio calculator, it's going to say 0.8. If you have a calculator that converts it into a decimal, it's going to say 1.25. 0.125. 0.125. Uh-oh, look at that. Okay. So then, again, without even doing the math, I'm going to guess that this is 1/16. I'm going to put it in my calculator. My Casio calculator, tells me 1/16. Your calculator maybe is going to say 0.0625. So in words, it says, when x is positive, the y values are increasing by multiplying by another 2. When x is negative, the y values are going to decrease by dividing by 2. So what we write for the rule for negative exponents, when you have, I'm going to write it using the letter, I think usually we use A for exponent laws. A to the power of -x is going to be 1/a to the positive x. And so sometimes the questions will ask for exact form or rational form, which means that you have to leave it as a fraction. So if you have a question, let's do 2, we didn't do 5, right? 2 to the power of -5. Then you make it a fraction under 1, 2 to the power of +5. Okay? And then in your calculator, you're not going to worry about the fraction. You're going to type in 2 to the power of 5. And that is exact form or rational form. Okay, you're going to leave your answer not in decimal form. So if you ever wondered why your teacher was so adamant about these Casio calculators and how annoying it is that they leave it in a fraction, this is one of the reasons. A lot of times we do not want decimals. Okay, and then the rule for negative exponents is not so bad, because no matter When you have a to the power of 0, it's going to be 1, no matter what. Okay? So let's do some more examples. So every time you see 0, you can put 1. Negative a to the power of 0, 1, no problem. B is a little bit tricky. The negative is outside brackets, or not a part of brackets. So what that means is it's like negative 1 times 8 to the power of 0. So this is a tricky trickster question. So then it's going to be negative 1 times 1, which is negative 1. Okay, but still, the 8 to the power of 0 is still 1. Okay? When you get to questions like D, you're going to make it a fraction. Why did I make it a fraction? I'm told, exact form, leave your answer as a fraction. And then you get 1 over, you can put in your calculator. You could put, if you have a Casio calculator, you can put a fraction, 1, and then in the bottom of the fraction, you can put 6 to the power of 2, and it should give you 1 over 36. If you don't have a Casio calculator, you just make the fraction and then put 6 to the power of 2 in your equation or in your calculator, and then write it down as a fraction. Same thing, and then this question over here, the negative 6, I'm going to make an ugly question for a second, but I want to get rid of the negative exponent. Yes, we do not leave our answers with negatives in the bottoms of the fractions, but it's the same idea. Put negative 6 inside brackets and square it, and you get positive 36. Or type in your calculator using the fraction button, 1 over negative 6 in brackets squared, and it should tell you 1 over 36. Okay? So this is the homework for the exponents. Give those a try. They really should not, if you remember the 2 rules, this should not take a long time. And I realized that because I'm using this weird version of the note, I forgot to do a question. So let's go back. Okay, because this is the FOIL homework here. Sorry. Or the expanding homework here. So we did a question, what happens when you have the graph to get factored form? That's like 11, and then 12 and 14 are questions like this one. You're not given a graph. So if the zeros of a quadratic are negative 12 and positive 10, so step number 1 for factored form is write that in. I'll even remind us what this looks like, the general form. Okay? Or you could have just changed the signs if that's what you like to do. Number 2 would be solve for A. So, I'm going to use the y-intercept of negative 360. What? That's okay. X is going to be 0. I chose a wacky y-intercept just to show you that it's no big deal. If we have big numbers, you just have to, maybe you don't want to do mental math. That's okay. 12, positive 12 times negative 10 is negative 120. And then if you divide the negative 120, you get 3. An A value of 3, that's okay. We know what that is. And now I just have to sub that in. No problem, okay? And now I'm going to take that and expand. So if you were worried about your factored form and you carried your mistake through correctly, I would not take marks off twice. I'll write this in black just because it's hard to see. So, the difference will be better. So we're going to FOIL and collect like terms. That's how we get to standard form. Okay? I'm going to FOIL first. So x times x squared, x times x is x squared. X times negative 10 is negative 10x. 12 times x is positive 12x. 12 times negative 10 is negative 120. I'm going to collect the like terms first. Negative 10 and positive 12 is positive 2. The 120 cannot be collected. Okay, and now this is what you did in grade 9. Now we distribute the 3. 3x squared plus 6x. And then we know we want the y-intercept to be negative 360. We're given that. What's 3 times negative 120? Negative 360. Excellent. Hopefully that means we're correct. Okay, so take a look at the questions. The first ones are with a graph. The second ones are given the numbers. Try to collect like terms. There's one of these questions on the practice test that now you can do. Okay, thank you.